Okay, children, once again, welcome back to the online tutor. So, in this tutorial, I'm going to continue the probability lesson, and so I gave some homeworks in the first probability video. So today, I'm not going to explain the answers of the questions, right? So today, I'm focusing very important two theorems, right? Two theorems in the probability, right? So let's move to the theorems. Okay, children, let's move to another theory part. This is independent events, right? So what is independent event? So independent events mean A and B are independent events. Therefore, PA intersection B will be PA into PB. This is the condition to be satisfied for to A and B independent, right? So what is exactly the independent means? So the A event is not depend by the B event. So B event is not depend by the A events to occur, right? Both are two events. No, there is no connection between, right? So some students are thinking if they are not occurring, if they are independent, there shouldn't be a intersection, right? It can be intersection, right? So because it's depend on the event, no? So this event and this event can be occurred simultaneously, right? But so the intersection means it's simultaneously happening, right? So the independent means both are not connected, right? So A is a one event, B is another event, there is no connection, right? Okay, but it can be happen simultaneously, right? Therefore the intersection is appear. So if it is independent, you should understand this is the condition to be satisfied, right? So using that theory, that part, I'm just going to prove you how to show if A and B are independent, show that A dash and B are independent, right? So this is from number one. If A and B are independent, therefore PA intersection B, which is PA, PB, right? So how to prove A and B dash are independent? So A dash intersection B dash, right? So in A dash intersection B, this is actually PB minus A, no? So PB minus A means PB minus PA intersection B, PB. What is this? This is equal to PA into PB. So you can pull PB out. 1 minus PA. 1 minus PA means PA dash. PB into PA dash, right? So A intersection B, which is equal to PB and P. Therefore, A and B dash, so A dash and B are independent. A dash and B are purely independent. So this is the way of proving A dash and B are independent, right? So let's move to the second Rome number. In the second Rome number, I'm going to show A and B are independent. Then we just need to prove A and B dash are independent. Then I'm starting again from A intersection B dash. So this is basically A minus B, no? Then PA minus PA intersection B. This is PA minus PA PB. So you can put PA out. 1 minus PB. This is PA into PB dash. Therefore, A and B dash are independent. So this is the way of proving A and B dash are independent. Okay children, the third round number. If A and B are independent, show that A dash and B dash are independent. So how to prove this? So I'm just again starting from P A dash intersection P B dash. So this is basically A union B. By using Morgan laws. This is 1 minus P A union B. Union B means PA PB minus PA intersection B. Alright? So what is this? This is 1 minus PA PB plus PA into PB using this one, equation number 1. Then I'm just writing 1 minus PA like PA dash. You can pull PB out. Then it's PA. Okay, what is 1 minus PA? PA dash PB. This is PA dash. So PA dash can be taken out. 1 minus PB. PA dash. This is PB dash. Therefore, A dash and B dash are independent. Right? So this is the way of proving A dash and B dash are independent, whether A and B are independent. Okay children, I'm going to an example. If the event A and B are such that PA intersection B equal PA PB, then A and B are said to be independent events. So now we already know it. Let C and D are two independent events. C dash and D dash are the complementary events of C and D respectively. Show that part A, C and D dash are independent events. C dash and D dash are independent events. I think these two we have done, right? Previous part we have done these two, right? I'm not going to explain it again, right? So you have to do it again, right? The probability of the, let's move to the application one, right? The probability that a man and his wife will live for at least 25 years after the marriage are 0.7 and 0.8 respectively. Find the probability that in 25 years both, neither, at least one, exactly one will be living, right? So the first of all you have to understand the thing that they given, the probability that the man and his wife live in 25 years, right, after their marriage, right? So they given the probabilities. Then I'm going to design two variables, right? Two variables. So A and B are my variables, right? So the A means a man, a wife, right? A wife will live at least 25 years. B means a man will live at least 25 years. So PA is already given, it's 0.7. PB already given, it's 0.8. Sorry, the man is, the wife, the probability that a man and his wife living 25 years, no. The man is 0.7, the woman is 0.8. First round number, both will be living, right? So both mean A intersection B, no? So actually A and B are independent. A and B are independent because the living of the man is not dependent on the living of the women, right? So wife. So it's basically independent, right? It's depend on their the health, right? So their health. Then this is can be written with PA into PB. So what is PA? It's 8 over 10, 7 over 10, 56 over 100, 0.56. This is the answer of the first round number. What is the second one? Neither. The neither means both are not living. So we prove it. If A and B are independent, right, A dash and B dash both are independent as well. PA dash means 1 minus 0.8. PB dash means 1.07. This is 0.2. This is 0.3. 2 into 3 over 100. 0.06. Round number 3. At least one. So at least one means this is neither, no? At least one means both can be live, right? At least, no? Then it's 1 minus the A dash PB dash. 1 minus 0.06. 0.94. Which is the third one. So the fourth one, exactly one. Exactly one means, what is exactly one? So it can be this way. A live, not B dash. B live, right? Not A dash. Not A. So likewise. So these are also PA into PB dash, no? PB into PA dash. So likewise. PA means 0.8. PB dash means 3 over 10. PB means 0.7. A dash means 2 over 10. Both 100. 24. 40. Alright. So this is 8 to 800. 0.28. Right. So this is the probability of living exactly one, right? So exactly mean a man can be living, but the woman should be dying, and the other way around, a woman is living, the man should be dying. So this is the way of the answering the last question. So I think these are known as independent events, right? The independent events knowledge is very important to understand the scenarios, the understanding the actual scenarios, right? So and the answering the questions like this way, right? Okay children, so the next question, a mathematical problem is given to 4 students A, B, C, D, C and D, whose chance of solving it are 1 over 4, 2 over 5, 1 over 2 and 1 over 3 respectively. If all of them try independently, find the probability that the problem will be solved, right? The problem will be solved mean 1% can be solved, 2% can be solved, 3% can be solved, and all can be solved, right? So the what is the probability of not solving? It's the complementary events of all, right? So first of all, I'm going to gather the data, right? So the data, we have A, B, C, D, 4 student, right? So this is the first person, right? First person solving the problem, right? So this is PA, which is 1 over 4. The next one, second person solving the problem, PB, it's 2 over 5. Third person, PZ, 1 over 2. Fourth person, solving the problem, PD, which is 1 over 3. Alright, so we just need to find the probability that the problem will be solved, right? So I'm just considering if it is not solved part, right? If it is not solved, P A dash intersection B dash intersection C dash D dash. So this one means no one solved the problem. No one solved the problem. And also A, B, C, D all are independent, right? These are independent, right? Each can try it, right? Each can make this complete answer, right? So there is no independent, so the one person to one person, no dependent situation, right? So therefore we can write it like PA dash, PB dash, PZ dash, PD dash. PA dash means 3 over 4, 3 over 5, 1 over 2, 2 over 3, 3, 3, 2, 2. Therefore, it's 3 over 20. This is the probability of no one solved. Right? So we just need to find the probability of the question is solved. Right? Question was solved. Question is solved. Anyone can solve, right? Then Px is 1 minus this one, 3 over. So I assume this is y, Py minus Py. Then 1 minus 3 over 20, it's 17 over 20. 17 over 20. This is the probability of, right? Someone can be solved. So it's easy, right? Okay, let's move to the next question. An item manufactured by a company consisting of two parts A and B. In the process of manufacturing of part A, 9 out of 100 are likely to be defective. Similarly, 5 out of 100 are likely to be defective in manufacturing of part B. Calculate the probability that the assembled item will not be defective. So we can assume part A and part B are not independent, right? So the defective, so being a defective of each part is independent by their others, right? Therefore, I'm just considering the part A defective, part B defective. So PA and PB was given, no? PA was 9 out of 100. This is 5 out of 100. So what is the probability that the assembled item will not be defective? So will not be defective means PA dash intersection PB dash, which is PA dash PB dash. Then it's 81 over 100, 25 over 100. Right? So this is basically 4, no? Then 81 over 400. So this is the probability of the assembled item will not be defective. So I think now you might have idea about the independent events, right? The independent mean the someone it's not dependent on the other one, right? So there is a intersection, but right, the intersection means simultaneously happening. No, there's X independent and the independent. So sorry, there X is a intersection. Then the intersection will be PA intersection PB. It will be PA into PB. So this is the independent scenario, right? So these are my examples of the probability of the independence, right? So now I'm going to another section, another theoretical part. This is very important part, right? In our advanced level probability, right? In combined mathematics probability, the conditional probability is a very important and very famous part, right? Decision tree, the decision tree, the decision tree mechanism also depend on the conditional probability, right? So you don't know why we are multiplied each leaf, no, right? So why we are multiplying each leaf? So the reason is the conditional probability. Like in grade 11, you had multiplied it, right? But you don't know why we are multiplied. So the teacher said to multiply, then you multiplied it, right? So there exists a theoretical background of multiplying each leaf, right? So that is the conditional probability, right? So now I'm going to explain the conditional probability definition. Let A be any events where PA greater than 0. The probability that an event B occurs subject to the condition that A has already occurred is known as the conditional probability of occurrence of the event B, on the assumption that event A has already occurred and it's denoted by PB over A equal PA intersection B over PA. This is a definition, right? So you don't want to prove it, right? So you can use it anywhere you want, right? So what is the conditional probability actually, right? So the thing is, the probability that an event B occurs subjective to the condition that A has already occurred, right? A has already occurred is known as the conditional probability of occurring of the event B of the assumption that the event has already occurred. So the something has happened, it's done, it's finished, and the probability of the other thing can be happen in way, right? So as an example, we can think like a man who has passed the LLS exam, a student who has passed the LLS. So I just need to find the probability of his being selected the university, right? So this is the conditional probability. The first thing is the capital A is passed the A-level subject, right? So all A-level subjects. Then the part B is the selecting the university, local university, right? So these are the conditional probability. This always the first event should be happen, right, before the second one, right? So this is the conditional probability. So the equation of the conditional probability PB over A. This is PB intersection A over PA. This is the conditional probability equation. So A has already occurred. So B in B, occurring B, right? So we are just considering the B event, right? Okay. Right. Next thing is multiplication rule of the probability, right? So what is the multiplication rule of the probability? If we cross multiply the above equations, we can obtain the following result. PB over A equal PA intersection B. So I will show it, right? So assume A and B are two events, right? So PB over A means PB intersection A over PA, no? So we can subject PB intersection A, which is PA into PB over A, right? So assume the other way around, A over B, right? This is PA intersection B over PB, no? So we can again subject PA intersection B, which is PB into PA over B, no? So these are equal, right? So these are equal. Therefore, the multiplication rule of the probability is PA into PB over A equal PB into PA over B. This is the multiplication rule of the conditional probability, right? So the both are equal. So the first thing is A happen, after A happen, B happen. So B happen, after the B, A was happen. So this is the multiplication rule. Both sides are equal. This is the multiplication rule actually. Right. Now just assume, right? Just assume if these two events are independent, then what will happen? If A and B are independent, so A and B are independent means PA intersection B will be PA over PB, no? So then PB over A can be written with PA into PB over PA. These cancel. PB. Right? So the first A event is happen. Then the probability of being B is directly equal to BB. Then there is no, right? There is no A terms on the right hand side, which mean B is not independent by A. The answer of the happening B, right? The answer of the happening B is not consisting the probability of A, right? So then these are independent events, conditional probability cases, right? Okay, these are theory. You just need to prepare your note. I think you all are preparing your note, right? So the step by step you just write the theory, right? So these are the theories, right? Okay, children, this is my example question, right? PA equal 3 over 5, PA intersection B equal 1 over 3, and PA over B equal 4 over 7. So we have to find the right hand side questions. Okay, the first one, PB. So PB means this is 1 over 3 multiplied by, the answer is same. The next one, B over A, PB intersection E, or P. This is 1 over 3, PA is 3 over 5, 1 over 3, 5 over 3, 7 over 12, 5 over 9. The third round number, B over A dash. This is PB intersection A dash over PA dash, which is PB minus PB intersection A, no? This is 1 minus PA. Actually this is PB minus A, no? PA dash. So this is 1 minus PA. PB means 7 over 12. Intersection 1 is 1 over 3. PA means 3 over 5. So this is, I am going to multiply it by 4. 7 minus 4 over 12. 5 over 2. Alright? 5 over 2. 15 over 24. The next one, PA dash over B. How to find that? This is PB means 7 over 12. Three over 7. The last one. A dash. Right, so this is PA dash intersection B dash over PB dash. So what is this? This is A union B whole thing dash 1 minus PB. This is PA. This is 1 minus PA union B, no? 1 minus PA PB minus PA intersection B over 1 minus PB. 1 minus PA me 3 over 5, PB 7 over 12 plus 1 over 3 divided by 1 minus PB, which is 7 over 12. So I'm just taking a common denominator, right? So you have to divide it. The 60 is a common term, right? Sixty minus 36 minus 35 plus 20 divided by 5 over 12, right? So the likewise 80 12, right? Then it's 9 over 60, 12 over 5, 9 over 25. So this is the answer of the fifth question, fifth round number. So actually it's so easy, it's not hard, right? So you just need to state the condition probability condition, right? Then you will get the answers, and you just need the previous tutorial knowledge as well, the sets knowledge, the Morgan laws, right? Those things are very important. Okay, so according to the conditional probability, I have something to prove you, right? So I have something to tell you, right? So children, this is the thing that I want to share with you. PA dash over B equal 1 minus PA over B. So how to prove this? I'm just going to starting from left hand side. Just write it down. Intersection B over PB, no? So what is this? This is PB minus A and PB PA intersection B over BB. I'm just going to divide it. 1 minus PA intersection B over PB. So I individually divide. So then what is this? This is PA over B. Right, so this is my RHS. It is proved. Right, the only thing is you have to state the condition. That's all. Right. Okay children, so this is the end of the probability second video, and so hope you all have learned about the conditional probability and the independent events, right? So the next tutorial I will discuss the total probability theorem, Bayes theorem, this whole thing, right? And also do your homeworks question, right? And thank you very much for being with us, and have a nice day.